So my name is Urška. I am a physics teacher and the IBDP coordinator at the International School of Curitiba in Brazil, although I'm currently on vacation, so I'm in Austria. I have been teaching IB since 2011, and I have been modeling since 2018. And I absolutely love it. And I've been working together with Francis and a few other teachers who are not based in the US, trying to spread the word about modeling.
Yeah, great. I'm Francis. I'm currently at American International School, Dhaka in Dhaka, Bangladesh, where I teach physics and theory of knowledge. I've been teaching IBDP since 2021, so this is my fourth year doing that. I've been modeling since 2017, 2018. And like Urška said, yeah, we've been kind of searching for the past couple of years of trying to get, modeling instruction off the ground and in an international setting. And we're excited to have you all here.
So because we have a pretty international group, maybe if you could just stick in the chat where you are right now, I think it might just be fun to see where people are. We've already got 3 continents.
Cool.
Pretty good. That's exciting.
That was the dream.
Yeah, this is
Yeah,
what we envisioned, right? This is what we envisioned. This is great. This is wonderful.
exactly. This is what we were hoping for. So, okay. Let's go ahead and get started then. It's my
So so we're just going to we did our introductions. We're going to kind of go in with kind of an introductory activity, kind of getting a taste of what modeling is and what it looks like, what it feels like as a student, talking about it from a teacher perspective as well. Then we'll go over a brief overview of what it is, how you could continue this sticky tape investigation into more model development and deployment, and also how it connects to the IB curriculum and learning goals. And then finally, Urška and I will share our own experiences with using modeling instruction in our IB physics classes and IB science classes. And then at the end, we'll have a question and answer session. You can ask any questions you have, or you can feel free to email us later those questions. Cool. So with that, I want y'all to put your student hats on for this. We're going to watch kind of a demonstration of what the sticky tape activity is. This is commonly used in modeling instruction classrooms that are talking about electrostatics and physics, for example. And after we watch the video, we'll put you into breakout rooms, and you'll create a whiteboard in those breakout rooms, and you will describe the interactions between what we see in the video. But with your student hat, we want to make sure you realize that, hey, we don't quite know what a coulombic interaction is, what the electric force is, other than our everyday experiences with static electricity, maybe having seen a balloon stick on someone's head. But you also have a basic cursory knowledge of kind of the atomic structures. There's some positive particles in an atom and some negative particles. Maybe the electron and the proton. But that's kind of where our student hat is. So in a minute, we'll watch the video, the first minute or so of it. And what I want you to do in your breakout rooms when we get there is to describe the following interactions between the top and top tape, between the top tape and the bottom tape, and between the bottom and the bottom tape. And in your description, make sure you include a written or a drawn diagram. We'll give you about 5 minutes. We'll check in on you and see how we do in 5 minutes. We'll add extra time as needed. Cool. So let's watch the video.
Hey, this is Horner, and I'm going to go through and show you how to do the sticky tape lab. It's pretty simple to do. You're going to take one piece of tape about this long, go ahead and stick it down on the surface of the table, and then you've got to fold over a little piece here in order to make sure that you can pull it up pretty easily. That's what we call the base tape. And then we're going to take another piece and we're going to stick it on top. And because it's on top, we call that the top tape. So I'm going to, now that I have it and it folded over, I'm going to mark it as a T. And that's the top. And then this is B for the base tape. So I'm going to do one more set. Now that we have our tapes down, next thing we're going to do is take the top tape and pull it off. So we'll pull it off pretty quick, and we'll set that top tape right here. And notice that it's already attracted to the wood. So we'll go ahead and see if we can get it to stick, and we can. We're going to take the other top tape, and we're going to get it close to the first top tape. So I'm going to take this and just get it close to that first top tape, and you'll notice that they do repel each other. So they're pushing each other apart, which is what is supposed to happen. Now we'll take a bottom tape and we'll try to get it close to that top tape. Let's see what happens. So bottom tape. And the bottom tape, when I get it close to the top tape, you'll notice that they do attract each other. We'll put this bottom tape over here, and then we'll take the other bottom tape, and let's see how the two bottom tapes interact. So this bottom tape, when I get it close to the other bottom tape, you'll see that they, again, do repel a little bit. And that's what we want to see with the top and the bottom tapes.
Okay. We'll stop there. Ooh, let me escape. Okay. And I'll stop sharing my screen too. Okay. So with that, Urška, can you put everyone to breakout rooms?
Yeah.
And in your breakout rooms, you should have a chance on the bottom of your screen. There should be a button for whiteboards. Maybe it might be under more on the three dots, but you should be able to create a whiteboard in your breakout rooms and use those. And then we'll share them together and share ideas in the full group. I'll also put the link to the video in the group chat if you want to take a look at it again in your groups. All right, folks. So do I have any group who would like to share their whiteboard first?
We can go.
Great.
So anyway, we went on Pivot. So if you're not familiar, Pivot Interactives, it's kind of got the sticky tape lab with particle diagrams. So we just stole these, but I don't know if they contribute or not. But so we have kind of our positive and negative charges, and then as the tapes separate, there's a shift in the quantity of each on each piece of tape, and so after that, there's an attraction between the net amount of charge on each tape. So,
all right. Can we have the second group share? Either.
Yeah, basically ours just showed like 3 sets of tapes attracting and repelling, and with kind of an arrow on it with forces, and that was kind of as far as we got.
Sure. Yeah, great. So at this point as a teacher, you could then, facilitate the discussion, what could we call this mystery force, right? This invisible force. At this point, a lot of times we would see, we have seen pushes and pulls that are done by hand or done by string or things like that. We've talked about gravitational forces as well. It's kind of the only invisible force we've seen. So at this point, you kind of direct discussion to think about, okay, what could we call this force and what are its properties, right? It's attractive, it's repulsive, these kinds of things. And then you can also extend this and say, okay, what happens when you bring the tapes closer? Does the force get larger? Does it get smaller? Does it stay the same? These kinds of things you can talk about and then add to your whiteboard diagrams as well. Our last group, do we have any chance that we saved that we had our whiteboard saved?
And we were trying to like be like a student. So, and I couldn't unlearn the things I had in my head. So maybe it was a little too, we had part of our diagram that was like more of an advanced student was kind of drawing it. But the part that we felt like most students would draw is like, show the tapes, draw an arrow. Vectors at this point, they probably have a little bit of an idea of an attractive force, repulsive force. And then I just decided to put a bunch of negatives on the repulsive tapes and then positives on the one that was, on the second set, when they attracted. And then we had a nice conversation about, well, do you think students would do that? Which charge would they even show a sign? And if they did, like which sign would they arbitrarily choose if they were even thinking about that? And so that was a good discussion that we had.
Yeah, it's an interesting thing to think about. I think, when I first introduced it to my students, they always have that exact same question, like, well, which one? It has to be one or the other. The bottom has to be positive or has to be negative. And then the question I always asked them, if someone snapped their fingers and all of the charges in the universe changed from positive to negative and negative to positive, would anything really change? Right?
Yeah.
No, it's a convention, right? So I think that's a great line of discussion to kind of tease out, especially with more advanced students who kind of have a bit more background knowledge about it. Definitely. Yeah, really cool. All right. So that actually was kind of the next step of our activity, was to look at kind of drawing a charge distribution for the top and bottom tapes. Let me just pull that up really quick. But I think we might just want to kind of move on ahead, since I think I saw a lot of drawings already showing charge distributions. So you would see again with students looking at these top and bottom tapes, you would ask them, okay, now imagine you can see at the atomic level, what would how could you represent what's happening in these tapes? Yeah. And again, a lot of students already have some familiarity thinking about positive and negative charges. They could start with that, putting positives one side, negatives on one side. I've never had a student like use different symbols other than positive and negatives, but I'd imagine there might be some who might do something like that. And then again, they present their ideas and why they chose their ideas. And we can, and again, at least the same discussion. Hey, why is the bottom tape positive / negative? Why is the top tape positive / negative? We talk about the idea of convention, that kind of thing. So yeah, I think, Urška, if you're okay with that, I think we're going to move on from this.
Yeah,
Cool.
sounds good.
All right. So just thinking about this as a teacher now, kind of what do you initially think about this investigation? Would you find it useful in your classroom? Specifically in an IB classroom, because we know how much content there is to cover in an IB science class. You know, is it worth spending the time on something like this? And how does an investigation like this align with the goals of the IB curricula? Thinking about, you know, the scientific investigation, thinking about inquiry-based learning. I know the IB talks a lot about these kinds of things. So, you know, what do y'all think? I guess what's your first gut reaction to something like this, to an investigation like this?
I think it's a great investigation. I think it's a great way to introduce the topic, just to get students talking, thinking, and trying to come up with a model of what's happening. And it, you know, it doesn't have to take very long to do this. You could, you know, depending on your class time, you know, a half hour or more, or roughly. And so it wouldn't, you know, as far as content wise, I don't think it would infringe too much on the IB, but it's a great way to get students involved in the topic at the start, I think.
Sure.
Mm-hmm.
Yeah, I find this. Oh, go ahead. Sorry.
Okay, I was
I was
gonna
just
say,
gonna say there was. Oh, sorry. Am I cutting someone off? Oh, it's the confusion. There's a comment in the chat that maybe it's not so useful for chemistry.
I teach chemistry and I do this lesson, and I think it's we do it to kind of introduce the idea that there are different types of compounds. Some have charged pieces, some do not, and therefore we name them differently. But I think for me, one of the things that I think is nice on this is that one of the things that a lot of our students in IB struggle with is that because the things we talk about are so specific and abstract and challenging, that they kind of look to us to kind of provide some sense of like, what is this actually supposed to be? What is the answer to this? As opposed to when we observe something, what are we constructing to explain what we saw? And so we frequently get questions about quantum chemistry or something of that nature, where the students want to know, well, yeah, but what is it really? Like, what does the electron really look like? And you're like, well, we don't know. We can't see it. It's not visible to us. We just invented this idea to describe this thing. And I think that can be portrayed well in this activity of like, all right, we saw something happen with the tape. We're representing it using pluses and minuses, but like, is that actually what's happening? I don't know. Like, it works to some degree, but also there are limitations on it. So that kind of the philosophical viewpoint of modeling, I think, is well articulated in that lesson.
Yeah, it's got, I think you hit the nail on the head. A lot of the students kind of that I've seen struggle with that concept of, hey, these models aren't getting to like the truth of the universe. Well, it's like, that's the truth, what we know from what we've experimented on and what we've seen, right? And everything that we do is a model. Everything we do in science is a model. It's a mathematical model or a graphical model or even pictorial like this. So yeah, I think you're totally right. And from what I've seen also, it aligns well to get students kind of start thinking about this philosophically, and you can even tie in some theory of knowledge stuff in there too as well, right? What's the truth behind science? Is science really getting the truth of the universe or not? Or are we always going to be bound by these models instead of thinking about what's the intrinsic nature of these things? Or is the intrinsic nature the same as the models? Really interesting questions you can bring up.
As a TOK teacher in the group that doesn't directly teach science, but supports Scott and Mark Hiskey that is on this call, is that I think that that's an element that so often teachers are feeling unempowered to teach TOK. And that is the element that I was going to say, is that if this is sense perception, an observation of the physical world around us, this ties into history, this ties into mathematics. Like, this is, I think, integral to setting up science. Of it's not just facts that my teachers are telling me and I'm memorizing them. It is really critical that we stop and say, like, okay, where else do we see this is my observation of the physical world around us? That is exactly what we do in history. We record, we document, and we create these models that explain the world. That is like identical to what we do in the human sciences. And so I think that that is a place that if we can support our science teachers having that TOK, those of you that have TOK, I heard a couple DP coordinators, like this is our work that we need to do. And even if it's a slow use of time or not an efficient use of time for all the content, this is our work as science teachers at a program, not just science teachers.
Yeah. And me and Urška talk about this a lot, is that we get initial student pushback from implementing this because they're so used to saying, you know, just having a stage on the stage, right? Give us the information, lecture, whiteboard, lecture, lecture, lecture. And we're asking students to, you know, I get so much feedback from my juniors and seniors saying, hey, why don't you just lecture to me? Why don't you just give me edutainment? And it's because they're not used to having to actually think in class all the time for 80 straight minutes, right? And this method really pushes that and really pushes students to, you know, think on their own and come up with their own explanations and then defend their explanations. Yeah, and that makes it an incredibly powerful tool as well. Yeah, absolutely, Casey. I as a TOK teacher as well, it's wonderful seeing the connections, right? It's very cool. Great.
Shall we go on to the next slide?
We shall.
Okay. So I think a lot of people are here already have familiarity with modeling instruction, but just to give an overview for those of you who might not, it is essentially it's a guided inquiry approach to teaching science, which is really about developing these coherent conceptual models. Research shows that a lot of students in science classes think that it's really just a whole bunch of disconnected facts. So here we're really teaching students how to create a coherent connection between all of those facts and actually to come up with their own models so that they can explain what they're looking at. It uses the modeling cycle to organize instruction. So the activity that we saw would probably be towards the beginning of the modeling cycle, but it's a whole series of activities that are carefully planned by the teacher to get students to develop a model and then to refine it and to deploy the model. It is very collaborative. So pretty much students are constantly working together to design experiments, to solve problems, to present to each other, to find the holes in other people's arguments, to work together to come up with an understanding of the ideas. And one of the important things about this as well is that teachers must be aware of common student misconceptions. So you're really trying to get students to confront some of those ideas that they come in with because of their everyday experience and allow them to come up with something that's closer to what our best scientific explanation is of those ideas.
Yeah. Yeah, as Urška said, the sticky type activity is like a paradigm setting activity. You go from there. So I mean, when my students get that charge distribution kind of model, you know, down with their understanding, then they can start to use that charge distribution, thinking about how circuits work and how potential difference works and all these different things, and it makes an understanding of potential difference and circuit construction a lot more intuitive. For example.
So this is just a model of what the modeling cycle looks like. You start out by observing phenomena, asking questions, analyzing and interpreting data. So that's kind of your model development. You're constructing your initial model, and then you start testing that model, asking questions through different sorts of activities, making predictions, and seeing how you can actually improve the model. It can be qualitative, like the activity that we did today. It can also be quantitative. So particularly in physics, a lot of these initial paradigm labs involve looking at relationships between an independent and a dependent variable, but it doesn't have to be. And essentially, you just keep on going through this modeling cycle, and your students are actually learning about science by doing science. And so that really aligns really nicely with the IB and all of those extra things that we're sort of expected to do as teachers.
Yeah, and the cycle does spiral upward as well.
Yeah.
Right. So you're constantly developing, then deploying, then developing, then deploying, and the students' understanding increases as time goes on through this cycle.
So these are just a possible use of how you might use the sticky tape activity. So Francis already mentioned that he does this when he starts his electricity. If you're doing electrostatics, you might start out with a sticky tape activity and then go on to a worksheet that are similar to what Francis showed, where you start to think about how the charges are distributed. You might move on then to looking at conductors and insulators. Another lab in here that is typically done actually using video analysis would be collecting data to derive Coulomb's law. So that would be more of a quantitative sort of lab. And then you could eventually move into electric fields. I think particularly from an IB perspective, that might seem really slow, but your students end up with a really, really good conceptual grounding that I think allows you to move a lot faster later on. And it helps teach a lot of those extra skills that they need for the IB as well.
Yeah. And with that conceptual understanding, students don't get stuck as often with ideas. I feel like I remember when I first learned what electric potential was, potential difference, I was clueless for years, even in university. And then honestly, looking at the modeling approach to doing potential difference in circuits, it just made so much more sense and it clicked right away. And with my students, I'm seeing similar things. So it takes time to get started with these. And then once they kind of grasp that foundational knowledge, it picks up really quickly.
Yeah. I'm not a chemistry teacher, so Scott, if you want to jump in, feel free. I just took this actually from some of the modeling material, but for example, if you were looking at internal structure, this could still be used within a unit like that. So it allows you to start thinking about the smaller scale structure of the atom, moving from a more particle model to having subatomic particles, and looking at patterns within the periodic table and then applying that to the structure of solids. So while it might not seem from immediately useful for chemistry, I think you could also use it for looking at ideas of things like bonding, because that all is based still on that idea of electrostatic attraction, which is actually a really important idea, I think, in chemistry as well. So having students understand that in a more real life situation, I think can make those concepts make more sense to them when they start applying it on that atomic level where they can actually see it. So for all of you who are IB science teachers, I'm not going to read these all for you, but these are the IBDP science course aims. There's a lot in there. And I think a lot of these are hard to cover if you are really just lecturing in your IBDP science class. One of the beauties of using modeling instruction is that as you're teaching, because it's all integrated, you're actually hitting a lot of these different aims. So, developing technology skills, if you're collecting data, for example, doing a video analysis to derive Coulomb's law, you're doing that in class. Thinking about the possibilities and limitations of science, I think when you're talking about what a model can and can't do, and you're also analyzing and evaluating and synthesizing scientific information. And so all of these discussions that students are having all play into all of these different pieces. So it's actually very strongly aligned with the IBDP.
Absolutely. So yeah, I can just talk a bit about what it looks like in my classes, my IBDP physics classes specifically. So I also implement a flipped classroom as much as possible. So kind of when I approach a unit, the first thing we do is or a subtopic even. The first thing I always do is do a paradigm establishing activity or investigation or lab. So like with electrostatics, I start with the sticky tape lab or activity, I guess. And then with, for example, for the particulate nature of matter, what I start with is I start with the diffusion of perfume or the diffusion of popcorn. So you can see this picture on the bottom left with the student drawing a model for how particles diffuse from a bottle of perfume through the room. And I have students essentially sit in the normal spots in the room and they raise their hand once they smell the perfume. And you can see the diffusion of the smell throughout the room by the students' hands raising one by one, and then they're required to model that. And then going on to looking at ideal gas law, I have the students at the top left, again, looking at the relationship between two variables that are in the gas law, and then graphing that, and then we share it all together and decide, hey, we seem to have enough data to realize this is probably the most likely relationship between these two variables, and then going on and applying that with the ideal gas law and so on. So with a flipped classroom, what's really nice is that I have more time to do things like this in class when it comes to these paradigm setting investigations or doing later labs when they're deploying a model instead of developing one, to have whiteboard discussions. I don't lecture almost at all in class because they have a chance to watch videos at home and then discuss them in class. The flipped learning also allows students to have multiple modes to engage with the content. So UDL is one of the things I try to apply as much in my classroom. I'm trying to get better at, and having, the way to develop models in class with the way we're doing this with whiteboard discussions and labs and investigations, but also them having that reinforcement at home of videos kind of allows students to engage in the content in multiple ways. And then finally, all of my unit assessments are not exam-based. They are usually open inquiry labs in the first year, and then later on they have different projects. So I actually had students make their own flipped video, and one of my students, who's typically not the best performer on exams, spent hours on his video and created an amazing piece of art and did an incredible job explaining the physics as well behind the topic that he chose, which was diffraction. So with that, in the first year, they get a lot of preparation for the IA. By the time they hit the IA, it's like, okay, this is just another lab report we've done, 4 of those this year already. It's nothing special to us, right? Other than the fact that it counts for 20% of their grade, of course. But the investigation itself, the only thing that's different from them is that it's totally open inquiry, and they have to think of their own topic with support from me. So by the time they get to the IA, they feel confident. They feel like they understand how to write scientifically. They feel like they understand how to create models, so best fit lines, work with uncertainty, these kinds of things. They've been doing it all year, sometimes formally, sometimes informally. Yeah, so I'll let Urška take over and talk about her experience.
Yeah, I think anyone who teaches IB science knows that there's always that pressure to get through the curriculum. And so there's a tendency to think, well, I don't really have enough time to do something that's inquiry based, but I really haven't found that's the case. For me, I've chosen to spend more time developing some of the really fundamental models. I spend a really long time on mechanics, pretty much using the full modeling cycle. I spend a lot more time on electricity and magnetism and on waves as well. And I feel like that allows me then to go through some of the AH content a lot faster. I can't do 100% modeling because it's just, I think I might need 3 years of course to do that. But I still can do teach the vast majority of my class that way. And I find that my students, one, just like physics more. I get a lot of kids coming in and deciding to take IB physics who aren't really your traditional physics students, which I think is really cool. But they buy into this way of learning because it makes more sense to them because they have a lot more agency because they're in control of their own learning. They're the ones who are taking part in the discussions and trying to figure out what's going on. So students are a lot less focused on finding the right equation, which I think in physics is often a big problem, right? It's just tell me what the equation is and then I'm going to solve it. And I think especially when you look at the IB physics exams, which cover such a broad range of material, when they have these coherent models that they can rely on, it actually makes them better problem solvers and they can do better in class. On the exam. Just like Francis said, the IA is really not a big deal for them. They do so many labs. I make them write some of them up formally, but not all of them. But because they have so much experience talking about how, what do the results mean, having to think about the uncertainty, having to design their own procedures, usually under a bit more of a guided format, that by the time they get to the IA, it's just doing what they've been doing. And so they don't get as stressed out about it and they have all the tools to be really, really successful. I just put a picture in here of one of my student whiteboards because I thought it's one that I kept because they had a question for the class in it. And I think that's a really nice thing that comes out of this is that it's not them looking to me for all of the answers, but looking to each other to try and figure things out and sort of saying, okay, this doesn't make sense to me, but I know that as a class we can put our heads together and solve it rather than just looking at the teacher as this sort of fountain of knowledge. And they learn pretty early on that I'm not going to give them the answers to things. Francis and I were talking the other day that we kind of start to get into our standard answers lately. I tell them I'm just a warm body who's been hired to substitute for their class and I don't know any physics, so they have to figure it out for themselves. But I think it makes them feel like they actually really know physics. And it's been kind of cool as well, just because I teach a 9th grade class as well using full modeling there. And it's been nice to see what they remember from the 9th grade. So when I start 11th grade physics, we start with energy, and they all remember their energy bar charts from the beginning of 9th grade. And one of my students said, well, of course I would do it this way. It just makes more sense, which I think as a teacher is a really wonderful thing to hear, because usually students don't retain a whole lot from year to year.
Absolutely. So any questions right off the bat, feel free to ask. If you have questions later, you can always send us an email. Our emails are here. Feel free to send us emails. We love talking about modeling, as you can tell. I'm sure we found it extremely successful in our classrooms, and especially in the IBDP. Just kind of, support what Urška was saying about the IA. I have solid evidence this year where the senior chemistry students, half of them were taking physics, half of them were taking chemistry, half of them were in physics and chemistry, half of them were only in chemistry. And the kids who were only in chemistry were lost for their IA in a lot of ways. And the kids who had taken physics with me knew exactly what to do for all steps, and we're not worried about their chemistry IA in any way. So we're passionate about this. We want to spread the word and make sure, people are informed. So ask away if you have any questions, feel free.
One of the questions I don't necessarily have, but I'm thinking about a coordinator hat. I'm lucky enough that I have Scott and Mark, who are both on this call, that can advocate and provide justification evidence for spending instructional dollars on modeling workshops. For teachers that maybe are new, and again, I don't know if there's some that are new here or not, it seems like a pretty experienced group, is that before a teacher would go to a coordinator or head of school and say, I would like to be trained in this, people that are the power holders and the money holders will be like, I need some evidence, because I'm just going to send you to an IB workshop, which we know is not going to provide this level of instructional practices. It's going to be more focused on written assessed curriculum. Is that what would be, are there resources that are, I guess, a marketing package of a concise way, not for, the wonderness and power of modeling, but if I'm going to justify spending $1,000 to $2,000 or whatever that modeling expense is, so that we can hand it over to your head of school coordinator on a plate and say, here's why you should spend this money. And that may not be from the two of you, but I don't know, on the AMTA website I'm thinking about how do we get people to move from a webinar to the 2 or 3 week workshops. We need some justification for said practice.
The website has a lot of good resources. There's also some research articles that, actually multiple research articles that you can use. There's a shorter one, I think it's by Jackson. Maybe Wendy could help me out of that one.
Jane Jackson.
Jane Jackson. She has one, doesn't she? That's kind of more of a summary one. That's fairly concise. That looks at results, I think.
Yeah, I'm not sure if there's new research. I'm sure that, well, there has to be new research, because Jane often has older stuff. There are scholarships, and I think Ray should be able to talk about that. There's scholarships to take a workshop.
Yeah, and Sue just put a link in the chat for we're going to provide some good information for you.
And Francis, we have, I think it's on the next slide, I added those 3 extra slides that Sue gave us that has some, that one. So yeah, there's the website, there's a lot of social media, but there are some, if you're looking at something, I think that's more maybe concrete, there are some older research articles that look at data of students who've been in modeling classrooms and how much better they do. So that might be something useful to try and convince people.
Yeah, I have the funds and I have the knowledge of awareness of this.
Yeah.
I'm thinking about, as we looked at the stated mission at the beginning of this was to spread modeling across, and I'm thinking about the suit in a C-suite that's got to spend the money. They don't have time for 4 pages. They need half a page. And so I look to support you all of I think this is great work and I want to help amplify it. I'm not a science teacher and I value it enough to come to this, is that might be something for Francis and Urška, that as you start this is how do we say, all right, here's the message for the power holders. Because also I see this as IB philosophy, this is it. And how do we help support a teacher in a school that you got to convince somebody to take a risk outside of an IB workshop, and this might be the place that they start.
Yeah, no, that's really good advice. And I know that there's a document that compares modeling to NGSS, but it would probably be useful to have a similar one that compares modeling to IB and makes that more explicit.
Yeah,
Thank
so I'd
you
love
for
to
that.
see this
Yeah.
in more schools.
But I think as far
Certainly.
as funding goes, so I'm in the Netherlands, used to live in Phoenix, where ASML is very big. I was at an organization, it's called Mad Science. It's in Eindhoven. All the schools in a 35-kilometer radius around ASML in elementary school, they are getting 6 workshops in science, in STEM. So I would assume that if you go to an organization that needs people in the workforce, you can go there, ask them for money. And that is something that Jane has been doing for as long as I know Jane. And I think I know Jane for about 20 years, maybe. So there's ways to get funding from local utility organizations, from international technology companies. So that's also a way to get funding outside of your school, and maybe you can do 50-50 or something.
Absolutely. But yeah, Casey, I think the half a page document or something like that that links research or cites research, I think is a really good idea. And I think Urška will probably look into that in the next month or two.
Can I jump in with a kind of related question to Casey's to kind of add? I think Casey's saying a little bit like sometimes we have the money. One of the things that both of you alluded to, we have a big issue when we go to things. Our district likes modeling until not everyone does it. And we can't legislate that teachers teach a certain way.
Yeah.
Can you talk a little bit about what your administrative response has been to the fact that like some of you are doing different techniques in your teaching? And I think that's another piece of that. Like, how do we get admin okay with some teachers doing this innovative teaching tool without everyone being able to do it immediately, and how to transition from that? That makes sense.
Yeah, I mean, I've experienced both sides of that. I've had admin who's been completely fine with me doing it and other people not doing it. And then I've had admin who have taken issue with the fact that I've been modeling because they want more conformity. And I'm not really sure, to be honest, what you can do with that. I do think that a lot of time teachers who are using modeling kind of clearly become the teachers that students like you tend to start to see higher enrollment in their IB classes, or you hear positive things from them, and that can often help admin change their mind about or become more open to it. But it is a little bit tricky, especially if you have admin who doesn't really know anything about science.
Yeah. I mean, yeah, I've always been in schools where they kind of allow us to teach how we want, for them, as long as, again, we're not raising any issues in any way with students learning. But as an example, I mean, this is my last year at my current school, and I'm moving on to a new one. And my assistant principal talks to me often about saying, how can I find a physics teacher like you that just gets the students to take more physics? Every year I get more than possible the requests for extended essays in physics. Usually I get 6 or 7 requests every year when I can only take 4. And if you've got administration that cares, I think you can point to that data and talk to them about it. When I first got to my current school, there was 1 7 in physics in the 6 years before I got here, and since I've been here, there've been 3 or 4. So I mean, I also have data to kind of back up that my instructional methods work. So I mean, also compiling that might be useful in terms of convincing colleagues or convincing administration that this is a worthwhile path to take.
Yeah, and can I just suggest the other thing is sometimes if you have a conversation with the administration about their larger goals for students, like evidence-based thinking, right? Student-based, student-centered instruction, student agency, right? There's lots of things happening in a modeling classroom that empower the student. to become an active learner rather than, passive recipient. And most administrators will get that. So it's to some extent, it's much about the student experience and the culture and climate in the classroom as, outcomes and results. I mean, you get the outcomes and results, but at the same time, to me, any administrator worth their salt goes into a modeling classroom and says, "Oh, this is how school should be."
I would say that also perfectly aligns with what the IB wants as well. Despite the fact that they, give an exam worth 80% of their final grade, what the game the IB is talking is, hey, student-centered learning, inquiry-based learning. We want our students to think for themselves and learn with direction from teachers, but not with just, regurgitating information they got from their teachers. So I think Raymond has a great point. I think any good administrator is going to walk into your classroom and say, wait a minute, this is the right type of science classroom. Great. Any other questions or anything to add? Okay, cool.
I think we
so I'll
have
just flash.
the QR code on the very last one.
Yes, this one.
Yeah.
So, Noel, if you could, we would love it if you could just take a quick survey. I know it's like the most typical thing for one of these things to flash a QR code at the end and you to spend more of your time doing this. But if you could spend 5 minutes or so just taking the survey, we'd appreciate it. I'll also link it in the chat as well for y'all, if it's not already linked.
And I meant when I asked the question to say also, I really appreciate you guys did this. Like, I really liked, it's a question that comes up a lot. How do you do this in AP and IB classes?
Mm-hmm.
Yeah.
I feel like there's a good amount of interest and overlap with the teachers who do modeling that teach those subjects. And I thought this was great. So thank you.
Thanks for being here. We're just trying to, build interest and it's been kind of a struggle sometimes. So we appreciate y'all taking your time to be here, especially some of y'all on a Saturday night. That's what I'm here for on a Saturday night, but I work tomorrow too in a Muslim country. So we have our Sunday to Thursday work week, but really appreciate y'all.
Yeah, and especially for those of you who aren't in the US, we are trying very slowly to try and get more stuff available that's not in the US time zones. So, stay in touch with us and hopefully we can offer some more opportunities as well that are at times that are not in the middle of the night for the rest of you. So,
So will the intro to modeling be at a time that works for continents outside of the US?
I mean, I would be open. I'm actually moving to Switzerland next year in August. So
you were in the leadership training, I think, was it? I don't know, in the middle of the night.
I was initially, and then I moved to Brazil, so it actually kind of worked out for me. But yeah, I am, since I'm moving back to Switzerland and I did the leadership training, I would be happy if there was enough interest to do an intro to modeling workshop that was maybe better aligned with European and Asian time zones. Yeah. If that's something people wanted, I think that maybe that's something we could look into for sure. Yeah.
Absolutely. So yeah, spread the word if y'all can. Like if this spoke to you, talk to your department, talk to people outside it at other schools around the world and try and I know Urška and I have been trying to spread this for a long time and it doesn't always click with people. But we're really passionate. We think this is, a wonderful way for students to learn and to connect with their teachers.
And is there a Discord channel for international teachers? Because I know we had people in other Asian countries, and I know there's people here in the Netherlands that are trying to do some in Germany, spread around.
I know that we talked about having, I think there is one. I know that I talked to Colleen about it after, because we had a workshop in Brazil last year and I know that we talked about getting it. We did have a coffee meetup going for a while, but we gave up after no one turned up after a year. But Francis and I are part of a small group that's trying to make a kind of international version of the modeling group. So if anyone would like to join us with that, just send us an email and we can get you involved. We once a month, and we're trying to think about things that we can do that work, because the time zone issue is hard for
Yeah.
sure.
And I also think, I don't know about y'all, but the people I work with, I would say 5% of them know what Discord is. So it might be a good idea. Maybe we could try a WhatsApp group or something similar to that instead.
Yeah.
Urška and I, we can have a conversation at our next meeting. And if y'all want to join us, feel free. It's the first Saturday of the month, usually, Urška, is when we meet.
Yeah, the first Saturday of the month. So if you would like to meet with us, you can just send either Francis or me an email, and I can stick you on our next meeting agenda. I see that Sue wrote that there is a Modeling Teachers International channel on Discord, so there is one there. I don't think there's been a lot of talk on it, but yeah, we are meeting the first Saturday of every month, sort of around a similar time to this, I think.
And there's also a link on the AMTA calendar on the website for our coffee hour, which is I believe.
I think that's not there anymore.
Oh, is it not there anymore? Oh,
I've been running it over the Google Meets. But yeah, if you're interested in joining us for that, send us an email and I'll just add you to the invitation. The more the merrier. We're happy to have more people.
Absolutely. All right.
Okay.
Thanks,
great.
y'all. Have a wonderful day, wonderful night, wonderful afternoon.
Yeah, thank you guys.
Thank you.
Yeah.
Great
Have a
job,
great
guys.
day.
Thank you for coming.
Thank you.
See you later.
Bye-bye.
Thank you.
Okay, bye.